Hello, it's Mrs. Garple here, and this is Unit 2, Lesson 4, Part 1. In this lesson, we are going to focus on finding a process for completing the square that works on all quadratic functions. We will be adapting diagrams to become more efficient in completing the square, and we will answer the question, how can we complete the square when there is more than one square given, or a doesn't equal 1 in ax squared plus bx plus c. So we are still working with Optima and her quilt shop. She bases her designs on quilt squares that can vary in size. So she calls the length of the side for the basic square x, and the area of the basic square is the function a of x equals x squared. In this way, she can customize the designs by making bigger squares or smaller squares. So in this first problem, sometimes a customer orders more than one quilt block of a given size. For instance, when a customer orders blocks of the basic size, the customer service representatives write up an order for a of x equals 4x squared. Model this area expression with a diagram. Well, let's begin with x squared, which is the basic area of 1 and has dimensions x by x. This expression for x squared is saying 4 times x squared, or x squared 4 times. So we can draw a total of 4 of these squares. And we would take care of the expression a of x equals 4x squared. In our next example here, one of the customer service representatives finds an envelope that contains the blocks pictured below. Write the order that shows two equivalent equations for the areas of the blocks. Well, we have the squares that we know are x squared from our previous lesson. We have rectangles that we know will each be x, also from our previous lesson. And we have the unit squares that help give us a complete square. So we can write one of our equations based off of the area of each of the different pieces. So we have x squared twice for 2x squared. We have x 3, 6, 9, 12 times for 12x. And we have unit squares 3, 6, 9, 12, 15, 18 times for a plus 18. We can also write our equation in terms of the dimensions of each side of the block. So we have dimensions of x plus 3 on each side of our block. So we can write a of x equals 2 times x plus 3 squared. And the reason we write it as 2 times is because we have 2 of these blocks. What equations for the area could customer service write if they received an order for square blocks that have both dimensions increased by 1 inch in comparison to the basic block? Write the area equations in two equivalent forms. Verify your algebra using a diagram. Now, verify your algebra using a diagram. You might think that the diagram is the last thing that you can do, but we can start with a diagram. So we're starting with our basic x squared that we know is going to be x by x. We are increasing each side by 1. And then I can complete it with my units, which, because I increased each side by 1, I only have 1 unit square. And these two rectangles are each 1x, or x. So our equations, we could write one just based off of the dimensions. A of x equals x plus 1 squared, or it can be the sum of the areas of each piece that makes up the block. So we have x squared, we have 2x, and we have plus 1. What if customer service receives an order for 3 square blocks with both dimensions increased by 2 inches in comparison to the basic block? Again, show 2 different equations for the area and verify your work with a model. So we have our basic square, that is x by x for x squared, and we are increasing it by 2 in each dimension. And then to complete that square, we're going to have 4 unit squares. But our customer service received an order for 3 of these. So I need to include another block with the same dimensions and one more block with the same dimensions. So my area can be written as, if I just use the dimensions, x plus 2 squared, but that expression gets multiplied by 3, so 3 times x plus 2 squared. We can also write it as the sum of all of the different areas. So we have 1, 2, 3 x squareds. We have 2, 4, 6, 8, 10, 12 x's for 12x. And we have 4, 8, 12 unit squares. And remember Optima's dog Clementine from lesson 3? Well, Clementine is at it again. That dog chewed up some more orders. Here are some of the orders that have been chewed up so that they are missing the last term. Help Optima by completing each of the following expressions for the area so that they describe a perfect square. Then write 2 equivalent equations for the area of the square. Well, we have 2x squared. That should tell us I need to have 2 of the basic squares. And since I have 2 of these blocks, this 8 needs to be divided amongst both of them. That leaves me 4x for each block. And if I'm going to increase my dimensions so that I have a square, I have to divide the 4 by 2 to get that I'm adding 2 to each side. So if we write our dimensions in these diagrams, we have x squared, we have 2x, 2x, and 4. We have another x squared, 2x, 2x, and 4. So if we look at this, we have x squared plus x squared is 2x squared. 2x plus 2x plus 2x plus 2x, that's 2x times 4, is 8x. So what we're missing is the added unit squares. So one area if I just complete that expression, that binomial to make it a perfect square trinomial, we have the 2x squared plus 8x, but then we have 8 additional units. And now that we know what the dimensions are, we can write area in terms of the dimensions. So one block has an area of x plus 2 squared. We have 2 of them, so it's 2 times x plus 2 squared. B, we have 3x squared plus 24x. Well, that 3x squared, I'm going to need 3 squares, 3 basic squares. Because I have 3 basic squares, this 24x needs to be divided amongst the 3 of them. So 24 divided by 3 leaves me 8. So I have 8x that go on each of these. But remember, we need to divide it evenly. So 8 divided by 2 becomes 4. And if we look at our diagram, and I know mine's not drawn to scale with the first one, but we'll have another x plus 4 times x plus 4, and yet a third x plus 4 times x plus 4. So our dimensions are x squared, 4x, 4x, and 4 times 4 makes it 16 units on each of these blocks. So x squared times 3 is that 3x squared. Four x times 6 is 24x. And then we have 16 times 3. This is the piece that's missing. So 16 units 3 times is 48. And if we write this using dimensions only, we have 3 blocks with dimensions x plus 4. So the area becomes 3 times x plus 4 squared. Sometimes the quilt shop gets an order that turns out to be more or less than a perfect square. Customer service always tries to fill orders with perfect squares, or at least they start there and then adjust as needed. They write their equations in a way that relates the area to the closest perfect square. So here's our first mess. Customer service received an order for an area A of x equals 2x squared plus 12x plus 13. Help them figure out an equivalent expression for the area using the diagram. In class, students recognized that we had 2 squares. So they said we must start with the 2 squares, which will then end up being 2 blocks. And then they divided these x pieces evenly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so that 6 of them would go with 1 square, and the remaining 6 would go with the other square. And then they took it a step further and divided those into 2 equal-sized groups to see that a plus 3 was added as the dimension to each square. So that takes care of all of these. Then they said, well, we need 9 units to complete one of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Completed one of them. But that we only had 4 left to complete the other. Well, if I completed this square so that it is a complete x plus 3 times x plus 3, I would end up with 5 other unit squares. But we don't have those unit squares. So when we write our area using the dimensions, a of x equals, we're going to look at it as we have 2 perfect squares that we begin with, so 2 times the x plus 3 squared, but we need to remove those 5 that create the perfect square. So we're going to, after the 2x plus 3 squared, we're going to subtract 5. In order to create the diagram or the quilt blocks that are being ordered. And in the last example for this part of the lesson, we have Optima again, really needs to get organized. She's got another scrambled diagram. Write 2 equivalent equations for the area of this diagram. So this time we don't even have one equation to work off of. We need to just work off of what is here. Well, since we have the 3 squares, we know we're going to be selling 3 blocks. And then these rectangles need to be split into 3 equal groups. So we have a total of 6. That means 2 per square. And then those get split in half for 1 per side, 1 per dimension. So we have x plus 1, x plus 1 for a total of 2 of them. And then I can take a unit square for each of my diagrams, so that takes care of 3 of them as well. But I'm left with these extras. We have a total of 1, 2, 3, 4, 5, 6, 7 extras. So let's write our equations. By dimension, I have 2 perfect squares that are, or 3 perfect squares that are 3 times x plus 1 squared in area, but then I have the 7 extra ones, so that's a plus 7 on the end. If I'm finding the total area of all my pieces, well, we had the 3x squareds. We had 6 x's, and we have the 3 plus 7 units for plus 10. And this is where the lesson concluded in class. We will pick up with number 8 in the next video.